What is happening? Why I'm not able to? Yeah, is this screen visible? Yeah, okay, so let's start. Okay, so today's topic is kinematics of rigid bodies. So, in rigid bodies, we usually see various types of motions. Okay, so, oh, yeah, okay, so the various types of rigid bodies motion can be grouped as follow. Okay, so what are those? The first one is translation. Okay, so in this case, I can say any arbitrary, any arbitrary straight line, any arbitrary straight line inside the rigid body, inside the rigid body maintains the same orientation during the motion. Okay, so in the case of translation, we will see that if you draw any, I mean, if you imagine any arbitrary straight line, okay, so during the motion, you will see that if the motion is pure translation, then the orientation of that straight line will remain in the same orientation. Okay, so if you take one example, suppose you have a rigid body, okay, and if you take an arbitrary point like a1 and b1, and if you imagine that there is a straight line, then if it is a translation, if after the motion, if the motion is pure translation, then this orientation of this straight line will remain same. Okay, so we can call it as a what, pure translation. Okay, and I usually saw that many people usually confuse. Can someone tell me, if I draw, this one is a case of pure translation, okay, pure translation, and the motion is like this. Okay, now I am drawing another rigid body. Okay, and suppose imagine a point a1 and b1, and then a straight line is same, but after the motion from position this to position this is like this. Okay, like this. Can someone tell me, is this example of pure translation or not? Tell me.
Pure translations.
Yeah, why is that?
It follows the accurate the point, initial point.
What? Please repeat.
it's follow the same position of that.
Not the position. You have to be very careful. Position is something different. Initially a1 is at this position and a2 has, I mean, the same point finally is at this position. But the main condition is this orientation of this straight line, this imaginary orientation of this straight line is remain same. So it is also a case of what? Translation, pure translation. Okay, so translation motion can also be categorized into two categories. Okay, the first category is called rectilinear. Rectilinear is called, oh, yeah, rectilinear, rectilinear translation. Okay, in this case the path is always straight line, straight line. Okay, and the second one is called curvilinear translation, is called curvilinear translation. Okay, in this case the path is curved line, curved line. Okay, so this translation is called curvilinear translation. Okay, and this is called what? Rectilinear translation. Okay, now suppose I am also taking one example like this. Suppose a rigid body is doing a circular motion. Okay, and on the rigid body, suppose I am drawing a straight line like this. Okay, and after some time it reaches at this point. Suppose it is doing a circular motion and after some time this rigid body reaches at this point and this straight line is like this. Is this an example of pure translation? Tell me.
Yes, sir.
Yeah, this is also example of pure translation because this orientation is not changing. Okay, orientation is not changing, so this is also a case of pure translation, but this time the rigid body is doing what? Curvilinear motion. Okay, so please do not confuse with this. Okay, now let's talk about the second type of motion, which is called, what was that color? Yeah, blue. Now let's talk about second type of motion. It's called rotation about a fixed axis. Okay, so in this case, in this motion, the particle forming the rigid body motion in a parallel plane along circle centered on the same fixed axis, okay, and this fixed axis is called what? Axis of rotation. Oh man, okay, wait, what, I don't know what is happening here. Why it is happening like that? Wait, I'm joining again, okay? Yeah. Okay. So, what I'm trying to say, in this case, the motion forming forming the rigid body motion in a parallel plane along the circle centered on the same fixed axis, and this is called what? Axis of rotation. Okay. So, what I'm trying to say, suppose, suppose suppose this is x-axis, y-axis and z-axis, okay? Suppose there is a rigid body, okay, and about z-axis this rigid body is rotating, okay? Now consider a point, consider a point P, okay? So when this rigid body rotates, then this particle P will make a circular motion, will make a circular motion about this plane, okay? And this axis will be called axis of rotation. Now let's talk about this point. Let's join this origin to point P is R, okay? Then you can see that if I name this point which joins this line is suppose B, then what will happen? Can I surely say that BP will always be constant? BP will remain constant because it is a radius. Okay. Now, if the rigid body is revolving around Z, then definitely at each and every point this angle will remain same, right? This angle will remain same. Then what can I write? I can easily write as what? BP equal to R sine phi. Okay. Now I want to determine the velocity of this point P. The velocity of this point P. Then what we will write? If I want to know the velocity of point P, then can I easily write as what? Vp equal to what? dr by dt, right? And this is a vector quantity, okay? If I take this as a scalar, then what we will write? Vp equal to ds divided by dt. And what is ds? Ds is nothing but this small integral distance. This is small integral distance. Okay. So if I write ds, then what we will write? Not ds. If I write delta s, then can I write delta s is equal to what? R. I mean that is BP. Okay. BP BP, okay, delta theta, and delta theta is what? This, whatever it is making this angle, okay, this is what? Delta theta. Okay, now if delta s is very small, if delta s is very small, okay, so can I write it as like this? Vp equal to, if delta s is very less, then can I write Vp d theta? At the place of delta theta, it will become what? D theta by dt. Okay, now at the place of Bp, we can write what? R sine phi. R sine phi. And this is what? This is nothing but the rate of change of this angle, where we can call it what? Omega. Okay, so we can write at the place of d theta by dt, we can write what? Omega. So Vp can be written written like that, what? Omega r sine phi, right? Now you can see that this is nothing but, it is, since it is in the scalar form of cross product, but if you write in the vector form, what can I write? Vp equal to omega cross r. Okay, and what is phi? What is phi? We can see that if you imagine the plane, if you imagine this plane, then you can see that in this plane the omega is this, and r is this. Then the cross product, if you write this plane like this, if you write this plane like this, okay, so this is what? O, B, and this is what? Suppose this point is P dash. Okay, I'm not talking about this point, I'm just talking about this point, and this is phi. Okay, then you can see that in this plane there is a omega, and this is what? R vector. Okay, then what will be the omega cross r? Omega cross r is same as Vp vector. And what is the direction of Vp vector? That direction is actually perpendicular to this plane, and which is nothing but this. So that's why at each point the velocity of particle P will be tangential to this circle. Okay, so this is the derivation of Vp equal to omega cross r. Okay, is there any doubt? Tell me.
No, sir.
Yeah, now let's move to the translation. What is happening inside the translation? Okay, okay, suppose I am drawing a coordinate axis where it is a z, it is x, it is y, and there is an arbitrary body. Okay, and in the arbitrary body, suppose there is a point A and there is a point B. Okay, and the position vector of point A with respect to this coordinate axis, suppose it is a RA, and the position vector of B is RB. And what will be this? I can assume that this is RB with respect to A. So from the concept of vector, I can write what? I can write RB equal to RA plus RB with respect to A. RBA I am writing, that is a vector which joins A to B. Okay. Yeah. Now if I differentiate this equation, then what will happen? If I differentiate the above equation, then what will happen? D by dt RB vector equal to D by dt RA vector plus D by dt RBA. Can someone tell me what will be the result? Tell me. Can anyone tell me what will be the result? Are you guys here or not?
Yes.
Yeah, what will be the result? So this will be the velocity of particle B, and this will be what? Velocity of particle A. And what will I write at the place of this? Tell me.
The value of RB, RA minus RB,
What?
RB equal to RA minus RB.
Again, you want to write this, right?
Yes, sir.
But there is no point to write like this. You will get 0 equal to 0, and that is always true because you are again using this equation. Okay, so here, since I have assumed that this is what? Rigid body. Okay, I am talking about rigid body, and in the rigid body, if the body is translating, then the relative position of point B, I mean the relative position of any arbitrary point with respect to any arbitrary point, that will remain same, that will independent of time t. That is the characteristic of rigid body, which means that this relative position, the relative position of point B with respect to A will not change with respect to time. So that's why it will become what? 0. Because I am writing here because it is a rigid body. So you have to keep this thing in your mind. Okay? Yeah. So in the case of, I'm talking about in the case of translation. Okay? In the case of translation. So because of rigid body. Now if you differentiate again differentiating, then what we will get? AB equal to what? AA. Again, this is the case of what? Translation. Okay, so what does it mean? It means that when body translate from position 1 to other position, if body translate from one position to other position, if the velocity of point this is suppose a, not a, is va, then after translating the position, I mean if the velocity of this point is va, then in the case of translation the velocity of this particle will also be a va, and also the acceleration will also same. Okay, so but this you have to keep in mind that this is the case of what? Pure translation. Okay, this is the case of pure translation, not in the case of rotation. Okay, now we will move to rotation about fixed axis. Rotation about fixed axis. Okay, then we will see what is happening here. Okay, so in the previous definition we saw that this is nothing but, if I talk about for the rigid body, then the velocity of point P was nothing but what? Omega cross r. In the case of pure rotation, okay, this is about what? Rotation about fixed axis means what? I am talking about pure rotation. Okay, now I want to find the acceleration. Okay, so differentiate this, what we will get? this will be nothing but AP. Okay, so AP vector, and you will apply a chain rule. Okay, yeah, not chain rule, that is some yeah, chain rule. Okay, yeah, this is the velocity of particle P. So this is what, this is nothing but alpha, and alpha cross r plus omega cross, this is what, velocity of particle P. Now if we extend, then we can write alpha cross r and omega cross, at the place of Vp what we will write, omega cross rp. Okay, so this is the acceleration in the case of pure pure rotation. Okay, now usually in our syllabus it's all about the planar motion. Okay, in the case of planar motion, then usually we saw that alpha is always in some z direction. Okay, so suppose if alpha is in that z direction and omega is also in z direction, that what we will write, AP equal to, just replace this. Okay, here alpha is constant. Okay, so, I mean scalar. Okay, so what we will write, k cross rp, here you will write rp. Okay, plus omega, I mean omega k cap into omega k cap cross rp. Okay, now simplify this, you will get alpha k cross rp. Okay, plus that is what, here you have to apply, you can separate the scalar here, so that will be omega square, and now it becomes k cross rp. Can someone tell me what is the formula of vector triple product? If I write A cross B cross C, then what will be the formula? Tell me. Hello. Why you guys are not responding? I mean, some, you have to say something. Okay, so that is nothing but a what, a dot c b vector. Okay, minus a dot b c vector. Okay, so just apply this here, so that will be AP equal to alpha k cross rp plus omega square, and that is so a dot c. Okay, so the first, this will be dot by this, so you can see that k cap and rp, k cap and rp, where is k cap and rp, k cap is this. Okay, and rp, so what will be the cross product, k what will be the dot product, k cross rp? Tell me. Hello. Definitely it will be 0, because k cross is perpendicular direction and rp is what, in this direction. Okay, so definitely that will be 0. Okay, so this will be 0 minus a dot b, so that will be what, k dot k, and that is nothing but 1. And what is this, that is rp vector. Okay, so you will get the acceleration of particle p, you will get minus omega square rp. So this is the derivation in the case of pure rotation. Okay, and this This is called tangential acceleration. This is called tangential acceleration, and this is called radial acceleration. Okay, yeah. So let's do one example. Is there any doubt here? Hello, is someone there?
Yes.
Yeah, is there any doubt here?
No, sir.
Yeah, so let's move to one example. I forgot to put that. Yeah, this one. Yeah, please try to solve it. Okay. Here it is a t equal to 0. Are you guys trying or not?
Solving, trying.
Yeah, try it. So what is the answer for A?
Would be approximately 120.
So it is asking the number of revolution executed by the pulley in 2 seconds. So what is the answer for that?
Making some mistakes.
Yeah, please rectify it. Okay, so it is a very straightforward problem. Okay, so let's solve it. Let's see what we are getting. Okay, so the first problem is, it is asking it is saying that the load B is connected to a double pulley, one of the two, yeah, most of the pulley is controlled by this cable, okay, which has the constant acceleration of 9 inch per second square. So the acceleration of this is what? 9 inch per second square, and the initial velocity is what? 12 inch per second, and both are in the same direction. Now it is asking the number of revolution executed by the pulley in 2 seconds. So in the first problem it is asking what? The number of revolution executed by the pulley. If you draw, you can see that this belt, whatever it is, this belt is a rigid body, okay, so whatever the velocity of point C is exactly the velocity of point this, okay. So now it is asking the what is the number of revolutions. So what will you do for that? Simply, what will you do? You will apply theta, okay, where we already know that theta is what? Omega naught t plus half alpha t square, right?
Yes, sir.
Yeah. So here it is saying that A is given, okay? Here it is saying that A is given. So, but we need what? Alpha, right? And alpha is what? Tangential acceleration. Here you can see that A is 9 inch per second square, which is nothing but the tangential acceleration, okay. So if A is 9 inch per second square, then what will be the value of what can you write at the expression of tangential acceleration? We already know that it is a tangential acceleration, then AT equal to what? R alpha, right? Tell me. Or alpha R, okay. So 9 equal to, we need alpha, and R is what? 3, okay. So from here you will get 3, okay, 3 radian per second square. Now substitute this into this expression, because it is asking the number of revolution executed by the pulley in 2 seconds. So just substitute, because yeah, here also we need omega, right? So here also you can get omega, okay. So V equal to omega cross R, so V equal to omega into R. So V is also already given, and omega we need it, okay, that is initial, right, into 3. So here we will get omega not equal to 4 radian per second. Now substitute everything. So here you will write what? Theta equal to omega naught means 4 into 2 plus 1 by 2 into alpha, okay. Here I have assumed that alpha direction is like this, okay. So that's why the direction of omega and alpha are same, that's why I have written positive, okay. So 1 by 2, alpha is 3 and 2 is 2, so that is 4. So you will get 8 plus what? 6, right? So that is 14 radian, okay, that is 14 radian. Now it is asking number of revolution. So how you will write the number of revolution? How you will write number of revolution?
Equal to omega t plus half alpha t.
Number of revolution will be 14 into what? Directly 1 by 2 pi, okay. So that will be the number of revolution, 2.23 revolution, okay. So this is for part A. What about the velocity and change in position of the load after 2 seconds? So how you will solve it?
ओमेगा टी प्लस हाफ अल्फा टी स्क्वायर से निकल पाऊंगा मतलब
It is asking velocity and change in position of the load B after 2 seconds. So it is asking velocity and but it is asking about this point, okay. It is asking for load B. So what will you do for that?
आर ओमेगा
But the problem is, what you will do for R omega? What is the omega? What is the omega after time 2 seconds?
वो निकलना पड़ेगा
Yeah, you have to find it, right? So yeah, you can do that also. So simply you have to find omega after time 2 seconds. So what will you do? Omega equal to omega naught plus alpha times t. Okay, so that is after
सर
time 2 seconds.
सर पार्टन में सर ये अल्फा टाइम्स टी होगा या अल्फा टी स्क्वायर होगा सर?
This is nothing but v equal to u plus at, and this is nothing but s equal to ut plus half at square.
हाँ,
Okay, so this is nothing but v equal to u plus at. Okay, so omega naught is already given, not given, we already determined, so that is 4. And what is alpha? Alpha is already given, or no, we have determined, so that is 3 into 2, so that will be 4 plus 6, that is 10 radian per second. Okay, now it is asking the velocity and change in position. So velocity is nothing but v equal to omega cross r. Here you can see that everything is same direction, so directly you can write v equal to omega into r, so that is omega into what? Here you have to write r equal to 5. Okay, because it is asking the velocity and change in position of this block. So whatever the velocity of this point will be exactly the velocity of block B. So for that you have to take this radius. Okay, so you have to write simply what? 5, that is 50. Okay, 50 inch per second, because everything is given in inch. Okay, so that is 50 inch per second. Now it is asking the change in position, so what will you do for the change in position? So simply you will do what? Delta y equal to what? R delta theta, whatever will be change in theta after time 2 seconds. So here that is 5, because r is already given, and change in theta, the change in theta is nothing but what? 14 radian. Okay, so that will be 14, that is nothing but what? 70 inch. Okay, so the change in 70 inch. Now it is asking, yeah, that was for the part B. Now it is asking the acceleration of point D on the rim of the inner pulley at t equal to 0. Okay, so yeah. Yeah, so it is asking the acceleration of point D. Where is point D? Here. It is asking the acceleration of point D on the rim of the inner pulley at t equal to 0. Here t equal to 0. So what will you do at t equal to 0 for the acceleration of particle D? AD, right? So AD equal to what? R alpha. Tell me. What will you do? Please respond, guys. At least you should respond. Okay, so first I will determine, because it is asking the total acceleration. So definitely we already saw that there are two types of acceleration, that is tangential and one is centripetal, or you can say radial. Okay, so for the tangential part, what we will write? R alpha. And since it is asking initially, so initially at for point D, that is 3, and what is alpha? Alpha you got that 3, that is 9 radian per second square, and that is the direction, that the direction will be what? Here in this direction, that is you can write I cap. Now you will write radial acceleration. Radial acceleration is what? Omega square r. Okay, so we have to put omega naught square, because it is asking at point t equal to 0. So what will be the omega naught? That is 4, so that is 16 into what? 3. Okay, so that is 48 radian per second square. Now it is in j direction, minus j direction. Okay, so now the what is the magnitude of total acceleration? That will be square root of 80 square plus ar square. Okay, when you put this and this, you will get 48.8 radian per second square, not radian, inch per second square, inch, because yeah, inch per second square. here you have to also write inch, not radian. Is that fine?
Yes, sir.
Yeah. So let's move forward. Yeah, let's take one more example. Okay, so after that we will move further. Yeah, see this example. Is it visible? Is it visible or not?
Yes, sir.
Yeah.
Yes, sir.
Yeah, solve this problem, this problem. Yeah, okay, so let's solve it. First, it is saying that there is a wheel A, okay, and this wheel A is rotating with some omega, okay, with constant angular speed, which means this omega is constant. Now, this, underneath this, there is a larger wheel, okay, and it has some thickness. It has some thickness. Yeah, it has some thickness, and in underneath this there is another wheel. Okay, so this is wheel A, this is wheel C, and this is wheel B. It is saying that there is no slipping occur. There is no slipping occur between point of contact between A and C, and similarly with B and C. So if there is a no slipping, then what does it mean? Which means that whatever will be the velocity of point this, that velocity will be same as the point this. Okay, is there any problem? What happened? So suppose I have assumed that the velocity of this particle is v. Okay, so if there is a no slipping, then definitely the velocity of this particle will be same as v. Okay, now if omega is constant, then what we can write? Omega equal to what? Omega equal to what? V by r, right? Or suppose this is the radius of this wheel now, or you can write v equal to omega r a. Okay, yeah, or yeah, suppose the omega the angular velocity of a is omega a, then you can write v equal to omega a r a. Now I already told you that these two velocities will be same. Now consider the omega of wheel C is omega c. Okay, then what can you write? Omega c for this point, for this point. Suppose the radius, this radius is suppose the capital R and the thickness is t, then what can I write? Omega c equal to V. This V divided by what? R plus T, right? Now replace V from here, then what can I write? Omega A, okay, divided by what? Not divided by, Ra divided by R plus T. So can someone tell me which one is larger?
Omega BC.
Okay, that is if I divide, yeah, definitely R plus T is larger than Ra, right? Ra is definitely less than R plus T. So what does it mean? Which means that if Ra is less than R plus T, then by the multiplication of this, omega C will be lesser than omega A. So which implies omega A is greater than omega C. Am I right or not?
Yes.
Tell me. Yeah, you can write everywhere as a omega A. Omega A. Yeah. Okay, so is there any option matching? No, right? No option is matching because yeah. Okay, now no option is matching. Now let's talk about for the wheel B. Okay, so the wheel B is underneath of this. Okay, so suppose whatever will be the velocity of here, I don't know. Okay, whatever were the velocity of this, we don't know. So suppose that is v dash. So whatever the velocity of v dash is, that will be exactly same as the velocity of this. Okay, because there is a no slipping. Okay, so what can I write here for v dash? For v dash we can write v dash equal to what? We don't know omega, we don't know the omega of B, so we can write omega B. Okay, omega dot omega and what is the radius of this? That radius is same as Ra. Okay, that radius is same as Ra. You can what?
19.9.
Why 19.9?
R omega square করলে তো alpha 19.
It is not asking for the acceleration. Okay, yeah, you are talking about option E, right? Yeah, I'm just solving. Okay, let's see. Now I'm solving this for v dash. I mean, just saying, just looking at what is the angular velocity situation at for wheel B. So that will be omega B into what? Radius is same. Okay, so now I have to also find v dash. I have to also find this v dash. Okay, so that we can substitute here. Okay, so what we can do for v dash? Okay, again same again apply the same situation for this wheel C, and now I have to find v dash. So for that, omega is same for this wheel. So omega C equal to what? V divided by, for this V divided by capital R plus T. Okay, exactly equal to v dash divided by what? R, right? Now from here I can find v dash. Here I can find v dash. So v dash equal to simply what? Omega C. Omega C into what? R, right? Now substitute v dash here. Now substitute v dash here. So v dash is equal to what? Omega cross omega, not omega, omega C into R equal to omega B into R. Now I have to write omega B, and omega B will be what? Omega C R divided by R. Okay, now you can substitute omega C from here and substitute omega C, that will be what? Omega C equal to omega A Ra divided by R plus T into R, that is that is Ra. Simply you can write Ra divided by what? R. You can easily see that omega b is not exactly, omega b is not exactly same as omega a. Am I right or not? Tell me. Omega b is not exactly equal to omega a, so this option is also not correct. Okay, now it is asking which one is larger, omega a or omega b. Can someone tell me which one is larger?
Omega A would be the larger.
Hmm?
Omega A.
Omega a. How is that? Yeah, surely, because you can no, not omega a, I mean omega b will be larger. Here you can see that ra, here ra is a square. Okay, now you are dividing with lesser than this quantity. Okay, so the surely you can so see that what omega b is less than omega a. Okay, so omega b is less than omega a, so this one is, yeah, this one is correct answer. And what else? Yeah, we got omega a is greater than omega c. So now we have to talk take that the contact point between a and c have the same acceleration. Now it is asking the contact point a and c have the same acceleration. Is that correct or not? Is that correct or not? Is that the acceleration between point A and C, will that correct or not? Tell me. Let's find it. Let's find it.
That would be different, sir.
Hmm? Definitely that will not be same, right?
Yes, sir.
We can surely say that that not be equal to same. Okay, so the correct, because yeah, I am not doing here because we already have the same problem but with the data. Okay, so we can easily find it everything here. Okay, now it has given that the rc is given, rc is given what, capital 55 mm and t equal to 5. Now you can you find it, the angular velocity of ring C? Please find it quickly. What will be the angular velocity of VC?
Doing
That is very easy. We already got that. We have to just find the answer. Here you can find omega C. So what is omega C? Omega A is already given. That is what? 300. Now you have to write RA. RA is what? 24. Divided by R plus T. So that is R plus T, that is nothing but 60, right? You will get 120 RPM. Okay, so what that is the omega of this larger wheel. So that is the answer for part A. For part A, yeah, we got two part. One is omega C. Now the second part is, it is asking what is the angular velocity of omega B. Omega B we also have to find it. By the help of omega C, we can easily determine. Please tell me answer for omega B. Tell me. Now let's solve it. So we need to find angular velocity of wheel B. So this is the wheel B. Okay, we have to find omega B. Okay, but before to find omega B we need VB. Okay, but we don't know VB. But whatever will be the velocity of this VB, we need omega B. Whatever will the velocity of this point, that velocity will be exactly same as the velocity of this underneath point. Okay, and from that we already know what this omega, and that omega is what 120. Okay, now find V from here.
275.
Yeah, 275. Okay, now we have to find this V. This V is what? Omega C, means 120 into what? 55 mm. Okay, mm per second. Okay, now substitute this V here. Okay, so 120 into 55 equal to what? Omega B into R, right? Yeah, so from here you will get omega B equal to 275 rpm. Okay, now we have to find the acceleration. Is that any problem here? It is very clear cut. What
909.
what acceleration? Acceleration for which wheel? I mean acceleration of the point A on A and C. So it is asking the acceleration of this point. First it is asking the acceleration of this point, and then it is asking the acceleration of this point. Now we have to find two accelerations. We have to find the point of contact between A and C, that is nothing but, suppose this is a AA, and then it is asking the acceleration of point of contact between B and C. Now assume this acceleration is AB. Now we have to find the acceleration of this. So first we already know that whatever will be the acceleration here, that acceleration will be same as for the wheel A, right? Because there is no slipping. Okay, so what will be the acceleration of wheel A here? That acceleration will be same as here, right? And what is this acceleration? Yeah, we don't know the acceleration because I am not sure about the direction. So direction is not correct. Okay, because we are not sure. Because yeah, you can see that there is no tangential acceleration. So definitely there will be radial acceleration here. Okay, am I right or not? There is no tangential acceleration, so we cannot show acceleration direction in this direction. There is only radial acceleration. That is because of r omega square. Okay, so the acceleration at point A will be what? Minus r omega what? A square. Okay, so that is nothing but minus 24 divided by 1000 into 300 into 2 pi. I am converting rpm into meter radian per second. So you will get here, that is AA. Okay, so it is a straightforward. There is no tangential acceleration part, so that's why I have omitted here. And this part is only a radial part, that is nothing but the towards the center. So this is r, that is nothing but the 24 mm. That's why I have converted into meter. Now this is I have to convert into rpm into radian per second. So you will get here minus 23.7 meter per second square. So this is the acceleration of this point. Now there is no slipping, so whatever will be the acceleration at this point, that acceleration will be exactly same as this point. Okay, is that correct or not? Tell me.
Sir, which one actually I got automatically logged out due to internet, poor internet connection?
You logged out. I am logged out or you?
I.
Yeah.
It's me due to my poor
Yeah.
network
Okay.
connection.
Okay. So did you solve it or not?
Actually, I got one is 19.9.
19 point. Yeah. Yeah. That is correct. For B, right? For AB.
Yes.
Yeah.
Hmm.
So that is correct. So now I have to find this acceleration also. Okay. So you have to draw the wheel B. Okay. So what will be the acceleration of this point for wheel B? That acceleration will be exactly same as for this point. So suppose this wheel is rotated by omega b. So what will be the acceleration for point B? So that is nothing but a b. Okay, and again there is a no tangential acceleration. So you will get what? You will get, that is here Ra. So that will be Rb omega b square, and when you convert it you will get the same radius you have to put. Okay, now that is 275 into what? 2 pi divided by 60 raised to the power 2. You will get negative. I'm writing negative because it is in the radial direction. So that is what? 19.88 meter per second square. So this is the solution of the problem. Okay, tell me, is there any problem? Yeah. Now let's move to the further topic. So the next topic is, earlier I talked about only translation and pure rotation. Now I'm talking about general plane motion. Okay, so general planar motion, where there is a mixture of rotation and translation. Suppose there is a surface, and on this surface there is a wheel which has moved from point this to point this. Okay, and this is the initial t equal to 0, this is the t equal to time t, and this point which was earlier a1, now it has moved to a2, and this top point that was earlier b1, now it is b2. So you can see that this roller has moved from point this to point this. Okay, then you can see that whatever is the changes in the orientation, that is nothing but it is the superposition. It is the superposition of two types of motion. It is the superposition of two types of motion. The first motion was pure translation. Okay, and that translation is what? This point a1 has moved to the point a2, and again it is a pure translation, which means what? The orientation of this line will remain same. Okay, because it is a pure translation. Now it has rotated. Now this orientation has rotated by some angle, and that is what? That is this. Okay, so now b1 dash has reached to the point b2. Okay, so this is what? Pure rotation. So you can see that from this orientation has changes to this orientation by two operation, that is pure translation and pure rotation. This one is one example. Now let's take another example. Suppose there is a guide and there is another guide, and there is a roller. Okay, and in the roller there is a link. Okay, now this roller has moved to this position. Actually, yeah, you have to show it by dotted, so that's why you could understand. So suppose the earlier it was at this position. Okay, now after some time this roller has moved at this position. So when you realize this motion by superposition of two motions, then how will you imagine? So when you talk about the pure rotation, then you can see that when I talk about pure rotation, pure translation, then you can see that this roller has moved from point this to point this. Okay, and for each and every point the distance, the changed distance are same. Then you can see that the orientation, I mean, you if you draw any straight line, the orientation is same. So this is what pure translation. Okay, now rotate this link by some angle. Okay, now rotate this by some angle, then what you will get? You will get the same as the final position. The same as final position. So this is what? This is pure rotation. This is pure rotation. So which means that every kind of planar motion that can be realized by the summation of or the superposition of pure translation and pure rotation. Okay, so now let's move to another topic, that is what is called absolute and relative velocity in plane motion. Okay, so let's look at this. Okay, now I will take an arbitrary body. Okay, and there is a point which has the velocity va, and there is another point that has velocity vb. Okay, now this motion can be realized. This motion can be realized by what? Pure translation and pure rotation. Okay, now I want to write the velocity of particle B. I want to write the velocity of particle B in terms of particle A. Okay, so I told you that any kind of planar motion can be realized as the superposition of pure translation and pure rotation. Then you can see that if there was a pure translation, then definitely if the velocity of this particle was VA, then the velocity of particle B was also VA, right? Now, since I want to write the velocity of particle V, I want to know the velocity of particle B. Okay, now you can see that if there was a pure rotation, then definitely this orientation, the orientation of this line might have changed. The orientation of this line might have changed. Okay, then what happened? From this orientation might have changed to this orientation. Then what will be the velocity because of this rotation? That velocity will be nothing but omega cross r, and this is B. If this is a, then RBA. Okay, so this velocity because of pure rotation. So which means if I want to write the velocity of particle B, then I can write it as the sum of this velocity, which was translation velocity, plus the orientation with respect to A might have changed at some angle or by some angle. So we can write omega cross RBA. So if the rigid body is in general motion, general planar motion, then the relative velocity of any point can be written. The relative velocity of any point with respect to any point can be written by this equation. Okay, is there any doubt? Tell me, is there any doubt here? Now, suppose if the motion is planar, if motion is planar, then I can write omega equal to something k cap. Okay, so VB can be again written as VA plus omega, okay, k cross product RBA. Okay, so this is the velocity of particle B with respect to particle A. This is the relative velocity. Okay, now let's take one example. Suppose there is a slaughter. Okay, and in this slaughter a link is attached by two roller. Okay, and it has given that if the velocity of this roller is VA, and I want to write what will be the velocity of roller B if it is constrained to move in this direction. If it is constrained to move into this direction at this instant when this link is making an angle theta and the length of this link is L. Now I want to write the velocity of this roller. Okay, so we will use the same equation, okay, the above equation. So it has given that, or it has already given that the velocity of this roller is in J direction. Now I am assuming the reference axis like this. The reference axis like this. Okay, this is X, this is Y. Okay, now it is already given that the velocity of roller B is in Y direction. So we can write VB b and what minus j equal to what, and this velocity is given in x direction, so you will write vai, okay, plus now I don't know what is the direction of omega. Since you have written omega as this, then you can assume that this link is suppose rotating as in this direction. That's why you have written omega cross. I mean, it is a default direction. We don't know. Okay, it depends on the magnitude of va and vb what we will get. Okay, so that's why I have written omega k. Okay, so that is nothing but the in z direction. So omega k cross. Now you have to write the position vector of b, I mean the position of b with respect to a. Then what will be the position vector? That is nothing but in the x direction, that is L cos theta, and in minus j direction, so that you will write minus L cos theta I cap, okay, plus L sin theta j cap, okay. So now simplify it, you will get this is what k cross I, that is nothing but j, so minus omega L cos theta j, and this is what k cross j, that is nothing but minus I, so you will get minus omega L sin theta I cap. Now compare I with I. When you compare I with I, then there is a no I here, then you will get VA. You will get VA equal to omega L sin theta, okay. Now from here you will get omega, here you will get omega, I mean there is a relation of omega, there is a relation of omega, that is omega VA divided by L sin theta. Now compare the j, you will get VB equal to what, omega L what, cos theta, right, cos theta. Now substitute omega as this, you will get VB equal to VA, and L will be cancelled out, that will become VA cot theta, okay. So which means that if you want to determine omega, at this instant, if you have the velocity of this roller, then you can easily get by this expression, and not the expression, by this equation. And there is a relation between velocity of roller B with velocity of roller A at this instant when the angle is this theta, okay. So this is the thing. And there is a one more important point you need to note, that the angular velocity, this is very important point, the angular velocity, okay, of the angular velocity omega of a rigid body, okay, you have to keep this in your mind, rigid body in plane motion is always independent, okay, independent of the reference point, which means that omega, if you have the omega of any rigid body, then it doesn't depend on the reference frame, it always remain same, which means that omega doesn't change with the frame, okay. If you have the omega of certain rigid body, and suppose you are assuming that it is rotating about something reference point, then someone is assuming that it is rotating about something point, then the omega will remain same, it does not depend on the reference axis or reference frame, okay. Is there any problem here? Is there any problem? Is that everything good? Tell me.
No, sir.
Is that good?
No problem. Yes, sir.
Okay, so let's do one problem with this. Okay, so this is the final problem, then we will finish it. Now solve this problem. Are you guys solving or not?
Trying.
Yeah. Now let's solve it. Okay, so in this problem it is saying that this is a double gear. This is a double gear, which means that whatever will be the angular velocity of this gear, that will be the same as this gear, or we can say that it is a kind of compound gear, right? Am I right? That is compound gear, right? This one is a compound.
Yes.
Actually I forgot, this one is compound gear, right? This is an example of. So initially it is saying that it has the linear velocity of point A is this, and this rack is actually fixed, it is not moving. Now it is it is asking to determine the angular velocity. So we will again use the same expression for the velocity of point C with respect to point A, because it has given the value of A, so easily we can determine whatever is that. Okay, so it is given that VC is 0. Okay, and there is one more data, that is what? VA is equal to what? 1.2 I cap. Okay, now substitute in this equation. Plus omega cross R what? CA, right? Okay, so VC is 0. Now substitute VA is what? 1.2 I cap, and assume that it is rotating in this direction. So not because otherwise we have to put positive, right? Negative. So assume this is in this direction, so that is suppose omega k, okay, into RCA. What is RCA? Tell me. If I assume origin here, then what is RCA? What will be the RCA? Yeah, but what is the value? I mean, in vector form, how can you write RCA?
150J.
150J, not minus 150 or 0.15, because with respect to this origin, this point is away. I mean, if you write RC minus RA, you will get negative. So 0.15 J. Okay, now that is 0 equal to 1.2 I plus omega, and here it is a negative. Okay, and what will be the value of K cross J? What is K cross J? That is minus I. Okay, so you will get omega equal to what? Yeah, here it is a 0.15. Omega equal to 1.2 divided by 0.15. Okay, and that is negative. Okay, because we are getting wrong direction. If we have assumed omega is this, then you will get the negative, which means that the omega will be rotating like, I mean this gear will be might be rotating like this. So the value will be what? 8 radian per second. Okay, and the direction is what? In this direction. Is that good? This is for part A. Now we are moving to a part B. It is asking the velocity of the upper rack, the upper rack R. So suppose if rack R is, there is no, definitely there is a no slipping between the rack and this gear, then what will be the velocity? Whatever is the velocity of this rack, that will be exactly equal to the velocity of the particle on this gear at point B, which means that we have to determine the velocity of particle B. So what will you do? VB, and we already know the value of VA, so we will find the velocity, relative velocity of V with respect to A. So you will get, you have to write VB equal to VA plus, and I told you that we have to use this omega, and this omega is what? We have, suppose we have now taken this as this direction, so you will write minus. This time I am writing minus because this is in minus k direction. So minus omega is what? 8 k cross, and what is the distance? This is distance, suppose, that is now it is a positive. Now it is a positive because with respect to A, this point is above, so that is 0.5 j. Okay, and we have to find VB, and VA is already we have, that is 1.2, and kj equal to minus I, that will be nothing but plus, that is what? 0.8, and this is I cap, this is also I cap. You will get what? 2 meter per second. Okay, so this is the velocity of point B. Now it is asking the velocity, point B means what? The velocity of this rack. Okay, this velocity of this rack, because there is a no slipping. Now it is asking the velocity of point D. Okay, so you again do the same thing with respect to A. Okay, now we will again use the same angular velocity. Okay, now the distance is different. This distance is different, that is what? That is 0.15. Oh yeah, earlier we have used wrong value, right? Yeah, earlier we have used wrong value, so here it must be 0.1, and here it also must be 0.1, but we are getting the correct answer. Yeah,
Sir, RCA is 0.15, sir.
RC, oh, where is RC? Yeah, RC is RC is same. RC is same. Okay, we are getting the same answer, right? Because I have already solved it. Okay, so but here it must be 0.1 because it is asking for velocity of point B. So that's why we have to write 0.1, because the radius is, this distance is 100 mm. Now it is asking the velocity of point D. So now this distance must be what? 150, but the position vector of D with respect to A will be in minus I direction. Okay, so that is minus I direction. Minus I into what? 0.15, and we already know that is 1.2 I cap. Okay, and that will be plus, and Kij, that also will be a plus, that is 8 into 0.15 Kij, right? So now it has two direction, 1.2 I plus 0.8 J, 0.8 J. So if you talk about the magnitude, that is what? 1.2 raised to the power 2 plus 0.8 raised to the power 2, you will get 1.697 meter per second square. And when you draw a vector, then you will get the velocity of D. The I direction is like this, that is 1.2 meter per second, and there is another direction, that is what? Not in this direction. Yeah, that direction must be here in this direction. Yeah, we are making some mistake here. Here we might be getting, yeah, yeah, that is correct. So that is 1.2 meter per second, and vertical it is what, 0.8 meter per second square. Not, yeah, meter per second. So this is the velocity. So when you draw the parallelogram, this is the velocity of point D.
Hello.
Yeah, tell me.
Sir, VD answer, sir.
VD answer is 1.697. It is,
Sir, in the last but one line, so 1.2i plus 1.2j.
no, that is 0.8, right? Okay, yeah, okay, yeah. So what is 8? 8 is that, 8 is correct, right? So that is, yeah, you are good, you are correct. 1.2, okay. Yeah, 1.2. The answer is correct actually. Okay, so is there any problem? Okay, so let's wrap up this session here. Okay, and in the next class we will talk about dynamics of rigid body. These things are all about the kinematics of rigid bodies. Okay, and then in the next class we will talk about dynamics of the rigid body. Is there any problem here?
No.
Yeah, so okay, so bye bye.